Relays. Useful little things. But for what? What are they? What can you do with them and how? Stay tuned. Hello once more, welcome to the desk. So, this episode we're going to have a look at some relays. Well, some relays, there are many more. We're going to look at what they are, what some of the types you can get, what can you do with them, how do you drive them, with and without a microcontroller. These things are actually useful without microcontrollers as well. We're then going to add one to the ESP32 board we've been working on, which I've managed to fix with a small update to deal with the uploading problem. We'll have a look at that later. So what we've got here is a couple of examples from my collection. These blue ones are complete modules. So these have got all the hardware you need to drive them. The little black thing is an opto-isolator, so they're properly isolated. The blue blocks are the relays. There's screw-fit terminals here. And yeah, that's basically it. You can literally stick that on your board. I use these things to control frog points, Diamond Crossing frogs. You give it down here a little 5-volt supply, a little ground supply, and you just feed it a signal on these pins in the middle. Or get this one here, there's more pins, and they switch the relays. We'll go into how that works in a minute. There's a little supply jumper on the side here. What you can also do with these is say, I want to use a separate supply. That's something I do because I use 3.3 volt logic. These relay calls really want 5, so I can put 3.3 volts in here, 5 volts in there, and it works. These are single pole double throw relays. So if you look at the little symbol here, what it is a switch. It's either on in that position or on in that position with a common contact in the middle. That's those. eBay, AliExpress, you can get them singles, twins, quads. There's 8s or in 16. So here we've got an 8. The 16 is like 2 of these side by side. It's not a really long one. These little beasties are latching relays. Now this is a bare relay. So you just pull it off, you've got little pins on the bottom, and you do things to it. This you need to provide your own driver circuit. We'll have a look at that later. They all have their uses. I say a latching one, you give it a pulse and it changes. You give it a pulse and it changes back on 2 different coils. These, you turn them on and they come on. You then turn the signal off and they go off. So these ones here useful for switches and things. The others, whatever. So they come in many shapes and sizes, like I say. For model railways, basically this sort of size is fine. I mean, these are miniature relays. There's lots of different types. We shall have a little look. So, what is a relay? Well, in its most basic form, a relay is a switch. And what you've got here in front of you is a single pole, single throw relay. Think a push button switch. When you press it, the switch is on. When you take your finger off, the switch is off. Well, here you've got a little electrical coil, and it is literally a coil. These things use magnetism. There are solid state ones that don't. I'm not looking at those. I'm just looking at these little miniature ones here. When you put power across the coil, typically on these case ones we're looking at here 5 volts, you can get 12 volt ones as well. You'll hear a click and the switch moves. The coil and the switch are electrically isolated from each other, so this is why you can have a 5 volt coil and switch quite a bit more. These ones here, for example, you can switch 240 volt AC with these, or 30 volt DC. It does matter. Don't try driving high DC voltages through these. You need special relays for that. What you find is the contacts weld themselves and then it doesn't switch anymore. So yeah, that's that one. You may be thinking, well, why not use a switch? That's one way to go, but the key with these relays is you can use one voltage to control another. For example, these ones, like I say, you use a 5 volt power supply to switch it, but it'll switch 240 AC or 30 volt DC. In your car, for example, you've got, a starter motor takes quite a chunk of electrical current. Electrical current needs quite thick switches, wires and switches when it's on a lot of it. Your ignition key is a small switch. Somewhere under the bonnet there is a relay. All your little key switch does, or your ignition button if you've got a posh car, it activates that relay. The relay activates the starter motor. So there you go. I mean, these model railway, you're driving them on 5 volts, maybe 12. You're probably switching 12 volt DC, maybe 15 volt DCC. These things here need 100, 200 milliamps when they're on. When they're off, they don't use anything. These latching ones use the same sort of current when they're switched, but because they stay in the same state, you use 100 milliamps briefly, then another 100 milliamps to switch it again. Depends what you want to do with it. Sometimes you want the ability for the thing to remember the position it is, and these will remember. If you switch them and then take the power away, they stay in that state. Sometimes that's useful, sometimes it isn't. Horses for courses. So let's have a little look at what some of the different types of relay are. So back with this one. This is a single pole, single throw. So it is basically, like I say, an on-off switch. This is as simple as it gets. In practice, you don't find these. You get them sometimes in like power applications, but you won't really find them in a model railway. What you're more likely to find is this sort, which is a single pole double throw. Now you can use this in exactly the same way. Again, you have a coil, you energize the coil, and funnily enough, things happen. You have a common connector, and this goes back to these blue ones. So if we go back onto here, this is what we have on these single pole double throws. So you've got the little switch, as I say, common. And if we look at this one, when there's no power, the common is connected to this side. When there is power, it's connected to that side. So that is normally closed. That side is normally open, which is what we've got on here. So when it's not powered, it's over this way. This isn't the exact pin out of the component. This is just a little schematic to show it. But this is a switch. Now you could say, I want this to be an on-off switch, or maybe a switch that's normally on that occasionally you can turn off. You could also use this with a 2-aspect colour light signal. You connect your power supply to the common, you connect a red to one of the switch outputs and a green to the other. And when you throw the switch, it'll switch between them. If you're operating that with LEDs, you may find, well, actually, I'll just use a switch and do it manually. If you're doing it with light bulbs, this might be better. But the other thing to note is, where you've got your little signal, it'll have 3 wires. Well, you can have all of that wired up over here, and you just have another signal wire coming in, or maybe 2 if you're using a completely separate supply. So you can control a signal with 2 wires instead of using 3. It's just one of those things. Or you could switch anything you want with this. The next sort is a double pole single throw switch. Now this is basically 2 normal switches, just on or off, and they activate together. They're completely separate electrically. You could have 12 volt on one and 24 volts on another, or 3 on one and 24, 5 volt, whatever. One could be wired so the positive is common, one could be wired so the negative is the common connector at the bottom. It's just 2 switches that work together. You can get triple pole, which is 3 switches. You can get quad pole. They start getting a little bit bigger at that point. It depends what you need. The sort of the big industrial type relays, you can have 6 or more contacts on these things, and all doing different things. The useful thing here, say you had this driving an isolated section on your layout. You can have 1 switch which drives the coil. You use one of these little contact sets to drive the isolating section. Maybe you drive the other one to put an indicator light on your board or flick a signal. There is also a double pole double throw. So here you could have your isolating rail section on one of them, and you could switch between a red signal and a green signal using the other. Fairly straightforward. They're basically the sorts of relays we're going to look at. I tend to use the single pole double throw and the double pole double throw. Even if you don't want to use one of the sets of contacts on them, it's fine. It doesn't hurt it. There is one other use for these double pole double throws that's worth mentioning while we're looking at it. and that is using it for doing polarity reversal. You can use this on reversing loops for DC and for DCC. You can use this with a motor where you have a speed controller, and what you want to be able to do is use the relay to reverse the direction. But what we got here is the previous configuration we had, and this is how it would normally be wired. So you've got a red wire comes in on the top and comes out on the top here as it goes through the switches, and a black wire comes in, or in this case a brown wire comes through. The key bit is the normally open and the normally closed of the two different switches are connected. So one's connected to the red wire, one's connected to the black wire. And if you throw the relay, what happens is the input side to side stays the same, obviously, but the outputs are now reversed. I mention this because I'm playing with these relays, partially because I'm coming up on building the reverse logic boards for the reversing loops on Leopard Street. So I thought I'll do a thing on relays before we dive into that. But yeah, that's some of the types. Like I say, they come in solid state. You can get much larger ones that can switch a lot more power. You can get ones where the coil voltages are higher. I really only use 5 volt ones. You can also get 12 volt, 24 volt, 110 volt relays as well, which I've worked on in the past on actual 1-to-1 scale trains. So yes, I used to be a technician on the trains. Please forgive me. Anyway, so the next section we're going to look at is what do you do with these things? I mean, how do you actually drive them? So, let's have a look at that. Now, this is the schematic from our little ESP32 board. There's been a couple of changes. The main one being I've added a relay onto the side with some lights. And there's also this little capacitor up here. We'll cover that in a minute. That's actually quite a useful thing. Now, driving a relay, if we ignore the microcontroller, you literally put your supply voltage across the coil. You don't need a resistor. The coil itself has got a resistance, and it is basically it's an inductor. It's a magnetic coil, little electromagnet. You're going to connect power. It'll draw its 100, 200 milliamps, and it'll energize. And you switch off and go. So you could actually just literally, where I've got this little transistor symbol, don't really worry about what a transistor is. You could just have a push button switch that would turn it on and off. That's if you want to drive one of these things manually with a switch. Very, very simple. Just use a switch to drive it. It's quite straightforward. This little diode matters because this is a magnetic coil. It will build up current. What inductors do is they resist the change in a voltage. So when you apply the voltage, it energizes, but it takes it a small period of time to energize. And when you switch it off, again, it resists that. It's got energy stored in it, which has to go somewhere. This is why you'll sometimes see switches that spark. And if you play with one of these things using bits of wire, again, you may notice some small sparks. Then, if using a 5 volt one, they're not particularly dangerous, but well, not to you. Microcontrollers don't like them. What you do is you put this diode across it. It's called a flyback diode. It's just a normal diode. And what it means is when you take the power off, the current stored in the coil has got somewhere to go. It just discharges through itself and through the diode. Protects the electronics that are driving the thing. The transistor, if you're going to use a microcontroller, you're going to need one of these. And the boards we looked at, so if we just go, if we just go back here, these have transistors on them. I'll just find something to point to because it's quite small. The transistor is this little beastie here, this little 3-legged thing. There's 4 of them. Here's the diode. So here's the little flyback diode as well. You've got a little transistor, there's a couple of resistors, and then there's the opto isolator. One of the resistors is for the opto isolator, the other one is to drive a little state LED, which is can be quite useful. But what the transistor does, the transistor's a switch. It will take a low current, and it will switch a high current. It's basically it's almost a relay, but it works in a different way. What we're doing here is I'm putting 3.3 volts onto the base here. That will turn the relay, the transistor on. An electrical current will go from 5 volts through the coil down to ground. done. And the flyback diode means it won't break the transistor when I turn it off. This little 1K resistor limits the current draw, so we're drawing minimal current. We're talking a couple of milliamps from the ESP32 to switch this on. I'm using 2N2222 transistors because I've got a big bag of them. There's a whole load of types. NPN, yeah, we'll cover transistors in another video. You can optionally put a resistor between the base and ground as well of something like 100K. What that does is mean when the ESP32 is not sending a positive signal, the transistor is off. Here it's going to always have a plus or a minus signal to it, so I'm not too bothered. So that's your little control circuit. It is very, very simple. You can also add another LED, which these, let's say, these little modules have got. One of the board configurations I've used before, you use 2 LEDs off this starting line. So basically, you'll always know whether your transistor is turned on or turned off, because you'll have one or other relay LED lit, rather. Sorry, and away you go. So yeah, I mean it's fairly straightforward. So here's your, let's say, your transistor, and then there's the other bits and pieces we've done. So wiring it up to the microcontroller is dead simple. It is a single wire. Later videos we'll look at driving these things using shift registers. So you can say, like, I want a couple of wires and I want to drive a whole stack of relays, which is how I actually do it at Leopard Street. We'll cover that in another video because that doesn't really affect the relay. So it's a single pin. You turn it on and you turn it off. If you remember how we did the LEDs, they're single pins and you turn them on and you turn them off. Hopefully this is somewhat familiar at this point. We'll look at the code in a minute. Just a quick one on fixing the little issue I had with the ESP32. Just going to shift a few things in my desk around here before we go back to it. So, let's come back to this and see if we can see it here. So here we are. This is now wired up. The relay is fitted. It's got some LEDs on it. The code is not yet here, but this is where we were last time. So if I press this, the servo moves. Incidentally, thanks to one of my channel viewers and subscribers, I'm going to put a link into it. He suggested setting up a GitHub. Don't worry if you don't know what that is. It's somewhere where you can go and download the code I'm using, so you don't need to squint at the screen and try and copy and retype it if you want to follow along with this. You can just go on and download it. This little beastie here has solved a problem. This is a capacitor. It is between the EN pin. So if we just go back to my little diagram over here, EN, which is enable, and ground. This solves the uploading issue. Basically, some of these boards have got a capacitor on them. It's a little one. Most don't. This means when this pin goes low and high, it's held there very briefly by the capacitor. It just helps the thing go into its switching mode, which is really, really nice because that means it works. So yeah, so here's the board we've got. What we've got, again, if I can find something to point with, do we need to get a pointing stick for up here? I don't have a pointing stick. I do have a load of relays that have just gone all over the table, however. Anyway, so what we've added, apart from adding the capacitor, over here, this yellow block is a relay. This is a double pole, double throw relay. There's another set of contacts on this side that I'm not using. Here's your flyback diode, which just goes across the coil. The coil is between positive, and it comes down here to the base of this little transistor, which is the pin in the middle. It comes down to the collector. Get this right. The collector, which is the pin on the right here. It then comes out through the emitter, which is the pin on the left, down to ground. For the sake of sanity, and because of the way round I've wired this, this is being powered off 3.3 volts, and it is working. Probably really should be a 5 volt supply to that, which obviously I've got down here, but wasn't up here, and there wasn't. Yeah, anyway. And I put in 2 more LEDs. These are just connected to the switch. They're not connected to the LEDs over here in any way. Witnessed by the fact that when that one changes, these pairs don't. So I just like watching the servo move. The LEDs have got their own resistors. Down here we've got the little 1K base resistor and a little wire that comes all the way over here to pin 32. Is it 32 I wired it to? No, I think it's pin 27 I wired it to. Yeah, it's pin 27. Yeah, ignore the diagram from earlier. That's showing it on the wrong one. I connected it to the wrong bit. So there we go. That's the wiring. Let's have a little look at the code. How's that going to work? So if I just do, and we will go back to here. So, what are we going to do with this? Now, I've added a little label at the top. You put the double backslashes in and you can type anything you like after it. It's just a comment. So the first thing I need to do is tell this where this is connected. So again, we're going to go with define. And we're going to go relay pin. And this one is connected to 27. Now, as I've mentioned before, having this little block at the top of the code that basically says, this is what I have got connected to this thing, makes a lot of sense. It's really easy to work out. If you want to plug a relay into somewhere else, you can just change it up here and you can see what you need. Other code we need is actually very, very minimal this time. What we need to do is we need to set this pin up. So I'm going to go in here, pin mode, relay pin. This is going to be an output because it needs to be an output. And because of the way I've set this up, which is actually wrong, but I wanted the LEDs to match. So the green is on the left and the red is on the right. Let's spell digital right, that might help. Digital right, relay pin high. So when we turn on, we're going to set the relay pin high to start with. Now the code is going to catch all of this and change. I'm not changing any of the switch logic. Don't need to change any of that because all we're doing is adding another output. So we go past all of this down here to where we drive the LEDs. So that one there. Well, I want the red LED to be on at that point when the other red LED is on. So digital right, relay pin, and in this case low, and that'll turn the red LED on the relay, because what that'll do is turn the relay off. So that means the normal closed bit will work. So I'm going to go in there, I'm going to say high in that case, and then down here the interlock code I don't need to change, and that's it. Literally a relay is driven by a single pin, so all you need to do is write to that single pin a high voltage or a low voltage, and you will control the relay. You want the transistor because the coil is going to draw 150 milliamps. If you try and take that out of one of these microcontrollers, you'll blow it up. You'll damage the innards. It won't work. Even Arduinos can't handle that. They only want about 20, 40 milliamps per pin. So the transistor, it works as an amplifier. So let's upload this and see what happens. So if I go upload and press the magic button, and we'll wait and hopefully it'll work. If it doesn't, I'm going to feel rather dim, but there we go. Won't be the first time. There we are. So that, yes, the capacitor has fixed that particular problem. So now in theory, if I press this green button, that green LED will come on as it did before. This servo will move as it did before, but now we're also going to switch this relay, which will change these LEDs. So let's see if this works. And that works. And I say, this is controlling some LEDs. If this servo was controlling a point, I could use the contacts on this side to control the frog polarity of that point. And then I could still have some lights on this side. So maybe these are for a panel or for a signal. So what I'm doing is with a single control line, I can control two LEDs and a frog polarity. And this is actually, if I go back to one of these boards here, this is actually how I'm doing the frogs, like I said, on Leopard Street. There's boards have got these things on. I mean, it varies which one they've got. Some have got 4, some have got 2s. One or two have got, I think one of them's got an 8-way board on it because it's got 6 points. Yeah, so that's that. It's fairly straightforward, but it's a little building block which is actually quite useful, because if you can drive a relay, you can drive anything that can be controlled by a switch. So, I mean, simple little examples. Don't mess with mains wiring unless you actually know what you're doing. You can control room lights with these things. There's home automation software that uses the an ESP32, and it's got a couple of relays. There's actually, I mean, you can get home automation boards that have got an ESP32 on them and 8 relays. And you set it up and you talk to it with your phone and what have you, and it switches the relays on and off. And those relays can be wired into, you know, something to open or close curtains, open and close windows, all that sort of stuff. But that's what we've got. Like I say, this one's quite a simple one. We are going to be building up some of the next episodes. I think we're going to look at these, which are sensors and other sensors. So what we're going to have is we now can control buttons as inputs. So again, if I do that interlock, we've seen how to do that. Turn the interlock off. We are going to look at see if I can get the button to do it. Of course it won't do it while I'm doing this. Yeah, anyway, we're going to look at debouncing buttons, which this one's been very badly behaved and refusing to bounce. So they're inputs. We can light LEDs directly as outputs. We've seen how to do sort of like software interlocking and things. We've controlled a servo, so we can start interacting with the world around our little controller. It could be driving a signal, level crossing gates, a point, moving a crane. You could do anything with them, anything that requires something that moves a little bit. We are going to look at proper motors as well in the future. And now with a relay, anything that just needs an on-off switch. So I'm going to be using these to drive, I say, the reversing loop sections. So if we just have a quick little look back here, I'm going to be driving this sort of circuit using a microcontroller. The microcontroller I'm going to be using for that is an Arduino Nano, which I believe I showed last time. I'll dig one of these up. It's this little beastie here, one of those. The reason I'm going to use one of those is because the circuit I'm going to be creating does not need to talk to anything else. It's going to be completely self-contained. But that's going to be an example of how to actually use a microcontroller to do something. It's going to monitor some sensors. It is going to have a few status LEDs because I like LEDs. Blinking lights, absolutely excellent. And it's going to drive some relays which are going to switch polarity for me. So we'll look at that in the next one, or look at something similar to that in the next one. Again, open to comments and suggestions and things you want. I will put a link to the GitHub page in the description. I will get this code uploaded onto there, so if people want to see that, feel free. It is very basic. It is very simple little steps. We are just turning things on, we are just turning things off at the moment. We're going to get on to doing slightly more advanced things. But in the meantime, I will leave you to enjoy the rest of your day. If the weather's nice where you are, enjoy it. If the weather's not nice where you are, my apologies. I can't do anything about it. Otherwise, I will catch you around. Thank you very much, and goodbye. It moves. Yeah.